Okay, this is lesson 3.7, families of quadratic functions. In terms of what a family is, a family of functions is functions that have common characteristics. And we can investigate what characteristics will be shared amongst quadratic functions by examining any invariant characteristics, or the things that don't change. So what I'm going to have you do is a little bit of an investigation. There's 3 different scenarios I'm going to have you work through, and the way I would like you to work through it is by using a graphing app. Specifically, the one I'm going to recommend you use is Desmos. You can use a graphing calculator, but I'd prefer instead that you use Desmos. So if you're not familiar with Desmos, it's desmos.com, and it's an online graphing calculator, and what it'll allow you to do is type in equations of quadratics and see what's common about these quadratics. So throughout the scenario, what I'm going to ask you to do is graph all 3 equations on the same axis and then draw a sketch. So just draw what it looks like. It doesn't have to be a perfect graph, just a sketch. So similar shape, and any important points that are clear you can label as well. List anything that they have in common, and then try to come up with another quadratic equation that would belong to the same family, so have that same common characteristic. So identify what in the equation is common and relate that to what on the graph is common, and then try to come up with another equation that probably has that same common feature, and you can check it by graphing it in Desmos. Make sure you list the common characteristics, and once you've done that 3 times, you'll see 3 different types of families of quadratics that you can have. The second part of the lesson, I recommend you do after the investigation. So what I might choose to do now is pause the video, do the investigation, and then pick up the video again after you've done the investigation. So the second part of the lesson is determining an equation of a quadratic function, and we can do that a couple ways. We can identify either the vertex or the zeros, and then write the function in either vertex form or factored form. Once you've chosen which form you're going to write the equation in, you substitute, and then you plug in another point that you know and solve for A. So I'm going to do 2 examples, one where we're given the vertex, one where we're given the x-intercepts. Now if you're not given either, there's an example of that as part C, and you can try to come up with what strategy you might use to find that equation, and we'll actually do it in class. So for A, I'm going to work through it. This says, for his accounting project, Brandon records the profit of a company from sales of MP3 players. This is a very old question. His data is shown below. These are how many MP3s are sold in thousands. So 0, 1, 2, 3, 4, all the way up to 9,000. And this is his profit in tens of thousands. So 83,000 loss. So he lost $83,000 all the way up to $25,000 profit. So we need to look at this and see if we're given x-intercepts or if we're given vertex. Now, if we're given x-intercepts, the x would be a number and the profit would be 0. And if we look, we're not given any profits with 0. We're given ones that are close to 0, so it's probably slightly over 3 and slightly before 9, but we're not given the zeros. So hopefully we're given the vertex. How you can tell you're given the vertex is you look for the maximum or minimum value, and you look to see if the points are symmetrical around it. And if they are, then you have the vertex. If they're not symmetrical, you don't necessarily have the vertex. So let's look. Looks like we have a maximum of 25 when we've sold 6,000, but 6 in terms of x. And if you look to the left and to the right, the numbers are 22, and then one more is 13. And then another step is -2. So it looks like we are symmetrical. And since we're symmetrical, we can assume that that's the vertex. Our vertex is 625. So to come up with the equation, we're going to use p of x instead of y and x for x. We're going to write a vertex form of a quadratic in and not fill in any of the variables yet. So we got p of x, a x minus h squared plus k. And now we can plug in our vertex for h and k, so 625. Now we don't have to use 6,000 and 25,000 because the variable takes care of that. X is in thousands, so we don't have to write 6,000. 6 means 6,000. And profit is in tens of thousands, so 25 means 25,000. So we don't have to worry about the extra zeros. And that's what P of X equals. And now to solve, we're going to pick another point. And you can choose any point to pick. The math becomes really easy if you pick an X that's 1 away, because when you start simplifying, you end up with 1. So to avoid the easy math, we'll make it a little bit harder. We'll go with, let's use 413. So we're going to substitute 413. You can pick any point though. 13 for P of X, and 4 for X. Now if you were doing this, you might choose to use 5 and 22 or 7 and 22, and the math gets a little bit easier, but I'm going to show you the more challenging math. Why are we substituting? Well, the reason we're substituting is because as we had it here, that's not a finished equation of a quadratic because we don't know what A is. Substituting leaves us with only one unknown, A, and then we can find out what A is and rewrite the equation with A filled in. So let's do a little simplifying here. I'm going to bring the 25 over and subtract. So we get 13 minus 25 equals A. And then 4 minus 6 is negative 2. And negative 2 squared is 4. And 13 minus 25 is negative 12. A times 4 is 4A. Last step, divide away the 4. We get A is negative 3. Therefore, now we can write our profit equation. P of X is negative 3, X minus 6 squared plus 25. Now what if we're given the x-intercepts or the zeros? Well, if you're given the x-intercepts or zeros, you're going to write your equation in factored form. Doesn't give us any context here, so we're going to use f of x and x as our variables. And factored form looks like x minus r, x minus s, with an a in front. The zeros are 2 and negative 1, so I'm going to fill those in. Minus 2, and x subtract negative 1 is like plus 1. And now I'm going to substitute my point. 20, negative 3, or sorry, 3, negative 3, 20, so 20 for f of x, and negative 3 for x. You substitute the negative 3 in both brackets. And now we got to do a little bit of math here. Negative 3 and negative 2 is negative 5. Negative 3 and positive 1 is negative 2. Negative 5 times negative 2 is 10. We got to be careful with this last step. For some reason, people always subtract in this step. Since it's a times 10, I'll rewrite it over here. It's 10a. We divide the 10 away. We don't subtract 10. So a is 2, and therefore we can write our equation. F of x is 2, x minus 2, x plus 1. All right, there's a video for writing equations. Now, if you were given graphs, you would just pick the features out of the graph. If you could see the vertex, you'd pick the vertex out and use vertex form. If you can see the x-intercepts, you take the x-intercepts out and use factored form. You always need another point. Y-intercept's a nice one to use, but really any point that you can read is a good point to use. Now, what if you're given both? Well, then you have a choice. You can choose vertex or factored form, it doesn't matter, because they're equivalent expressions, equivalent equations. If you can't read either, then you may choose to use scenario 3, which is a little bit more complicated, or it might be acceptable to estimate the vertex or x-intercepts. That's it for lesson 3.6. Thanks for watching, and I'll see you next time.